Let's start by looking at alcohols. Alcohols have the functional group OH, known as the hydroxyl group. They have a general formula ROH. Notice that there is no carbon implicitly shown here, but that we just use the R group to stand for the hydrocarbon chain. We are going to look at one major property of alcohols. For now, we are going to skip the solubility and boiling point of alcohols. I will talk about those later when I summarize all of the classes of compounds to compare their solubility and boiling point properties. For now, we're just going to discuss the fact that alcohols are not bases. The main reason I'm pointing this out is because a lot of people see the OH and their immediate thought is, oh, it's a base. Recall that to be a base, it has to start with a metal or ammonium and be ionic. In this case, the alcohols start with carbon and are therefore covalent compounds and cannot be bases. When we test the pH, we find that they are neither acids nor bases, but neutral compounds. Before we move on to the naming of alcohols, I would like to talk about the three subclasses of alcohols. The reason we mention these three subclasses is because they will determine whether an alcohol reacts in certain reactions. That means that you will need to identify these subclasses of alcohols. The three subclasses of alcohols are called primary alcohol, secondary alcohol, and tertiary alcohol. These are very similar to the primary, secondary, tertiary, and quaternary carbons that we learned about when we discussed the hydrocarbons. Recall that when we talk about primary, secondary, tertiary, and quaternary carbons, we look at how many carbons are directly attached to that carbon, not how many total carbons there are. So a primary carbon has one carbon directly attached to it. A secondary carbon has two carbons directly attached. A tertiary carbon has three carbons directly attached. And a quaternary carbon has four carbons directly attached to that carbon. You will need to understand that in order to do the three classes of alcohols. The first step in identifying these three classes of alcohols is to find the hydroxyl group, the thing that makes it an alcohol. Here we see the OH, that is our hydroxyl, and we'll see that this is a primary alcohol because that OH is attached to a carbon that is a primary carbon. That means that carbon has one carbon directly attached to it. For our secondary alcohol, we find our hydroxyl group, we look at the carbon it's attached to, and we see how many carbons are directly attached to it. We see that there are two carbons attached, making it a secondary carbon, and making this a secondary alcohol. For the tertiary alcohol, we look at the carbon the hydroxyl is attached to. We see that it has three carbons directly attached to it, making that a tertiary carbon, and the alcohol a tertiary alcohol. Notice that there is no such thing as a quaternary alcohol because we can't have an oxygen there because the carbon already has four bonds to carbon. So let's look at the next page of your notes, and we're just going to look at the structure and identify them as primary, secondary, or tertiary alcohols. We'll come back later and name them. Let's start with alcohol A. We find the hydroxyl group, we look at the carbon that it's attached to, and we find out how many carbons it's attached to. In this case, we don't see that there are any. This is actually not primary, secondary, or tertiary. This is called a methyl alcohol. But because of the way it behaves, it acts as if it is a primary alcohol. We're going to label it as a primary alcohol. Now let's look at alcohol B. We look at the hydroxyl group, we see which carbon it's attached to, and then we look at how many carbons are attached to that carbon. Remember, those hydrogens that are on the left-hand side are actually attached to the carbon before it. The carbon is attached to that carbon. That makes this a primary alcohol because it is attached to one carbon. On to compound C. When we look at compound C, we find the hydroxyl. We look at the carbon it's attached to, and we count how many carbons are directly attached to it. You should see that there's only one carbon attached to it. There are two other carbons, but only one is attached to the carbon that has the hydroxyl. This is again a primary alcohol. Now let's look at compound D. So looking at compound D, we find the hydroxyl. We look at the carbon it's attached to. we see that that carbon is attached to two other carbons. This one is a secondary alcohol. For compound E, we find the hydroxyl group. We look at the carbon it's attached to. We see that that carbon is attached to three carbons and is a tertiary alcohol. When we look at compound F, we see that there are three alcohols. When there's more than one alcohol, we have to classify each one as primary, secondary, or tertiary. Looking at the first hydroxyl group, we look at that carbon. We see it's attached to one carbon. It is a primary alcohol. Now let's look at the middle hydroxyl. We see that it is attached to a carbon that is attached to two other carbons, making this a secondary alcohol. And looking at the last hydroxyl group, we see that that is attached to a carbon that is attached to one other carbon, making that a primary alcohol. This compound is both primary and secondary alcohol, and it will take on the properties of both the primary and secondary alcohols present. The next lecture will focus on naming these compounds.